All right, can you all see that okay? So 009, graphing quadratic functions. So we're just going to go over, the parent function and how to graph it with whatever form you're given, because I feel like it really helps review a whole unit of Algebra 2. I think you remember that a quadratic is just the highest power is x squared, and the graph of a quadratic is always called a parabola, and the parent function has these key points. So if it's y equals x squared, when you graph the key points from -3 up to 3, those are the key points that we're going to be graphing for our parabola. So anything when you square it becomes a positive number, right? So -3 times -3 is +9. -2 times -2 is 4, 1, 0, and then the pattern repeats, 1, 4, 9. And that's what gives the graph its symmetry. So we're just going to graph the vertex at 0, 0. You go up 1, over 1 on either side, and then over 2, up 4, and then over 3, up 9. So there's your smooth parabolic curve. We call the vertex 0, 0. And then remember, it also has a line of symmetry, or axis of symmetry that cuts it in half, right? So that's the line of symmetry. So on some of the questions, you're asked, what is the equation of the line of symmetry? So it's this vertical line. So it happens to be x equals 0 on this graph, but if the vertex moves around, it's going to be a different equation. So the parent function is what you're going to come back to every single time, no matter what form you are given. So you need to know these points, 1, 1, 2, 4, 3, 9. You need to know them really well. So the standard form of the quadratic, I'll try to zoom out, Taylor, so you can still see it. So standard form is y equals ax squared plus bx plus c. And I think of it as the ABCs of a quadratic function. So each of these coefficients changes something about the graph, whether it's the concavity, the steepness, the y-intercept. So without having a graphing calculator, I should know a lot about this function number 1. I see a 2 there, so I know it's going to be steeper than normal. I see a 6 here, so I know the y-intercept is going to be at 6. I cannot identify the vertex from looking at the equation because I need to do a little bit of math. So your first step is, what does the A value tell you? In this case, it's going to be concave up, and it's going to be steeper times 2. So I always like to write down my ABC information. So A is concave up because it's positive, and steeper because it's times 2. The B information is how you figure out your vertex. Do you remember the equation to figure out your vertex in standard form? Negative B over 2A. Does that sound familiar at all? Negative B over 2A. So that's going to be something that you didn't have to memorize in Algebra 2, but it's a real nice to know in pre-calculus. So negative b over 2a helps you find the vertex. So that's the x value of your vertex. So we're going to calculate negative b over 2a for this function. The b value is -8. So if I need the negative b value, it's actually going to be +8 for this equation, because -8 would be +8. And then I'm dividing by 2 times 2 in the denominator. So 8 divided by 4 is an x value of 2 for my vertex. And then I'm going to write down plug in x to find y. So if you have an x value and you have a function, you're going to plug your x value into your function to find your y value. So I'm going to do 2 times 2 squared minus 8 times 2 plus 6. And then I could either use my calculator to evaluate this expression, do some mental math, If I did some mental math, 2 squared is 2, or no, 2 squared is 4, 2 times 4 is 8, so this is 8. I'm subtracting 16, so that would give me negative 8 plus 6. Sounds like negative 2? And you could check it on your graphing calculator, but mental math is always a good thing to practice too. So 2, negative 2 is my vertex. Normally, I would go 1, 1, 2, 4, 3, 9. If those points get stretched, so I'm just going to write 1, 1, 2, 4, 3, 9 up here, just so if anyone needs to look at this video, you can see what I'm doing. If I'm stretching it twice as tall, it's my y values that get stretched twice as tall. So 1, 1 twice as tall is going to become 1 with a height of 2. 2, 4 twice as tall is going to still be 2, but it's going to have a height of 8, and 9 would have a height of 18. So I'm going to go over from the vertex, over 1 and up 2, and then over 2 up 8 from the vertex. 1, 2, 3, 4, 5, 6, 7, 8. So that would put me up here at my y-intercept of 6. And that coincides with what the C value is telling us. So your C value, kind of the last thing, C value is your y-intercept. So in this case, 0, 6 is our y-intercept. We happened to go right through that point while we were graphing. So your graph, you might not be able to fit your y-intercept always, but in this case, we could. And then at the end, you might want to just check, hey, was this concave up? Yes. Hey, is this steeper times 2? Yes. So all this information should go together, should piece together to write your graph. So just show of hands, how many of you that sounded familiar, even if you forgot all the steps? It sounds familiar. Do you remember doing this in Algebra 2? Some of you it was 2 years ago, so it's probably like, yeah, I forgot all of this. But we're trying to bring back some of those steps. Even if, when you leave pre-calculus, even if you just knew this was a quadratic and it was a parabola, that would be pretty useful to know. But, the nitty-gritty steps are the skills that we're trying to bring back in our brain. So let's do a couple more together for practice, and then I might have you do, let's see, I'm going to do 2 and 5 and leave you to do 3 and 4 in a minute. So another thing that you can do first is you can identify your A, your B, and your C values before you start, just as a reference point. Remember, when there's no coefficient there, it has to be a coefficient of either 1 or -1. So my A value, right, it tells me that it's concave up, and it's just the same as the parent function, right? So it's going to just be 1, 1, 2, 4, 3, 9. The B value, I'm going to do my ABCs. So that reminds me that I want to find my vertex. So I'm going to do negative B over 2A. So let's see, negative B would become positive 6 divided by 2 times 1. So 6 divided by 2 would give me 3. Now I need to plug 3 into the original function. Right, so I'm going to do 3 squared minus 6 times 3 plus 4. So here was me just plugging it into the original function. 3 squared minus 6 times 3 plus 4. So I think we could do mental math on that. 9 minus 18 would just give me negative 9 plus 4. Sounds like negative 5. Check my math, because I tend to make mistakes when I'm talking in front of a group. So if I'm ever off, please correct me so that people don't get confused. So let's see. Over 3 and down 5. 1, 2, 3, 4, 5. There's my vertex. And I can go ahead and graph, right? Because it's concave up and it's just the parent function from the front page. So you should get really good at the parent function. Over 1, up 1, over 2 from the vertex, up 4, and then over 3 from the vertex and up 9. 1, 2, 3, 4. So it should hit your y-axis at 4, because that's over 3 up 9, and your y-intercept, is 0, 4. And that fits with our C value of 4. So everything should, link together. If not, you probably calculated your vertex incorrectly. And the only reason that C is your y-intercept is because when you plug in 0 for x, that term goes away, and you're just left with that constant term of 4 in this case. So I'm going to do one more with you. I'm going to do graph number 5, and then I'm going to have you try 3 and 4 on your own, and I can walk around and try to help you find the vertex correctly and, go through each step on your own. That's where I think the real learning happens, is you trying to apply it and seeing where you get stuck. And I'm in the room to help you, answer your questions. I'm picking this one because it's that -1/2. So I thought that might be a little bit more challenging to graph on your own. So A is telling you what? -1/2, B is -2, and C is 4 in this case. So A is telling me it's concave down this time, and it's half as steep. So half as steep is going to kind of look like this, right? It's going to rise and fall very wide. It's going to be a wide parabola. So when I get my vertex, I have to remember it's concave down because of the negative, and it's going to be half as steep. So my B value reminds me I'm going to do -b over 2a. So you've written that down 3 times now, so start to memorize -b over 2a. So I've got -2 again, so now it's going to be +2 divided by 2 times -1 this time. So I got to do a little bit of math. 2 times -1/2 is -1 in the denominator, and then 2 divided by -1 is -2 as my x value. And be careful, because if you're going to type this into a calculator, because I know some of you like to double check, if you're going to type that into a calculator, you'd have to type 2 divided by parentheses 2 times -1/2. Because if you don't put parentheses around the denominator, it's not going to come out to the right answer. So now I'm going to plug -2 back into that original function. So let's see, it's -1/2 times -2 squared minus 2 times -2 plus 4. So you could do that on your calculator to find the y value, or you could try doing it in your head. Order of operations, -2 squared would give you +4, times -1/2 would give you -2. So this is really -2. -2 times -2 is +4, and I'm adding another +4. So it looks like -2 plus 8 would be +6. Anyone try it on their own calculator, get +6? So -2, +6 is the point I'm going to plot. -2, 1, 2, 3, 4, 5, 6. And just like I did at the beginning when I was doing the stretch times 2, I might write down the set of points and do the shrink times 1/2. I know the negative flips it upside down, so I'm not going to record negatives. Just what would shrinking these y values mean? It means I go 1, but I only go 1/2. I go 2, but I only go 2. I go 3, but I only go 4.5. So it's the y values, right? These y values are what you're shrinking. The x spacing stays the same. So 1, 4, 9 becomes 1/2 to 4.5. And remember on the front page, I did it over here, and it was 1, 4, 9 doubled, 2, 8, and 18. So that's what stretching or shrinking does. It changes the y value, not the x value. So why is this crooked? Okay. From the vertex, I'm going to go over 1 and down 1/2. I'm going to go over 2 and down 2. So that should hit the y-intercept that I wanted, which was at 4, right? Double checking. Y-intercept was at 4. And then from the vertex over 3 and down 4.5. Sorry, the grid lines aren't super. 1, 2, 3, 4.5. So there is a less steep parabola than what I started with. So that's a lot of work for one problem, right? When we look at vertex form tomorrow, you're going to be like, whoa, vertex form is so much easier. Standard form has a lot of math and calculation and formula to get a graph. So maybe that'll help you appreciate your vertex form next time. So I'd like you to take a minute and try 3 and 4, and I'll walk around and see what questions